Wow, is it that time already? Chapter 5, new chapter time. Woo, awesome. Oh, cool. Straight up, functions and relations. Now, um, yeah, I don't know how to break this news to you, but there is some theory that you need to get an understanding of. Yep, some new words, some symbols and things like that that you need to actually think about and try and get your head around. Yep. So first thing we're going to have a chat about in this exercise 5A is looking at what's called set notation. Now, this form of notation is used in maths textbooks a lot, and you will need to understand them because moving forward in your maths, this is what gets used. Yep. So you need to be all over this. Here are the facts that you need to know. We'll go through each of these dot points. I know some people probably, your eyes will roll back in your head and you'll be like, Mr. Fan, this is a lot of information, but we just have to hold in there and understand this stuff. Yep. So first dot point, it says a set is a collection of objects. Cool. So you might have some numbers and things or objects together. They are a set. Perfect. Tick. Next, it says each of those objects that are in the set are known as elements. Yep. So if you've got a few different things in there, they're not called things, they're called elements. Sometimes as well, they are called members of the set. Yep. So if you hear the words members of the set or the elements of the set, they are each of those things that make up the set. Now, the notation that we use, it says if X is an element of set A, so it's a part of set A, you would write that using this notation. X is an element, it's that funny E looking thing, of A. Yeah. So rather than having to write out the sentence or whatever, E is an element of A, you know what's going on there. So as it says, E is a member of set A, or E belongs to set A, or X is in A. All of those things are talking about that. Cool. If X is not an element of A, this is cool. It's like X, and it's like the element symbol, but it's got the cross through. Yep, so not. Hang on, let me get my finger in the right spot. It's not part of that. So X is not part of A. Yep, cool. It says here set B is called a subset of set A. Okay, so what they're actually talking about here is in this example that we have over here on the side. Yep. So you've got some numbers that are in A, but are also in his set B here inside the circle. The numbers you can see here that are part of B, they are also a part of A. Yep, because B is inside A. Yep. So where you've got some numbers that are a part of another set, it's known as a subset. Yep. So set B is called a subset of A if every element of B is also an element of A. Cool. You would write that as B, and this little U on a side line, is the symbol for subset. Yep. It says the expression can also read as B is contained in A or A is contained in B. Cool. Now the other thing as well you'll note is this diagram here is made up of this information from the example. Yep. So here they're actually describing a set. So set B, and to describe a set, you have to say what it's equal to. You use the squiggly braces. Yep, those little things. Let me get my finger in the right spot to do the squiggle. They are braces, and in here you list each of the elements of that set using a comma. Yep. So obviously the elements that are part of set B are 0, 1 and 2, and the elements of set A are 0, 1, 2, 3, 4. You'll notice, as we said here, set B is a subset of set A because every one of these is in set A. Yep, so 0, 1 and 2 are in here, so it is a subset of set A. Yep. Cool. Hopefully that's that there. Oh, this is cool, more stuff. Yep. In case you were wondering, that diagram over here is a Venn diagram. Yep, the circles where things are overlapping. You may have seen some of these in year 10 as well. Yep, they're very popular to use in maths. Oh, cool. They're going to be revisited in chapter number 9, so that's something fun to look forward to in maths. Yep. Now, again, with set notation, these things are important. It says the set of elements that are common to both sets A and B is called the intersection of A and B. Now, when I think of an intersection, I think of like roads where they cross over, so it's in the middle where everything crosses over. Yeah, it's the same difference in Venn diagrams. It's where they cross over in the middle. Yep. So the intersection, let me get my pen. The intersection is obviously this middle part here where they overlap. Intersection of A and B. Now, when you are referring to this using set notation, you write it as A intersection. It's that symbol there. It's the intersection symbol. A intersection B. Yep, so it's the overlap of both of those. Yep, it's in that and it's in that. So another word that's used there is and. Yep. Cool. So using the notation here, it says X is an element of A intersection B if and only if X is an element of A and X is an element of B. Yep. So it's saying it has to be an element of both of those, set A and B, for it to be in the intersection. Yeah, so that's just another way of writing it. Cool. What's this? Oh, it says if sets A and B have no elements that are in common. Yep. So you could have A, imagine these are perfect circles, A and B, and there's nothing overlapping in the middle, then we say that they are disjoint. And what you would write is you would say that A intersection B is equal to the empty set. Yep. Or null, nothing. Yep. Yeah, there's no overlap. Intersection doesn't exist. It's an empty set. Yep. There's nothing there. Cool. I can delete my funky circles. Oh, this takes time. Sorry, you guys are being patient. Fixed. Alright, disjointed. We've spoken about that. Oh, the last thing we have to have a talk about is when the set of elements that are in A or in B or in both, and that is called the union of sets A and B, and it is denoted by A with the union symbol, B. Now again, with my weird brain, I remember the union symbol because it looks like a U. Yep. So generally the way I work it is I remember U is for the union. Yep. And that means the one that's upside down is the intersection, the other one. Yep. But you guys need to work out how you guys can remember the difference between the union and the intersection symbols. Yep. Cool. So when you've got A union B, they've got an example. Let A, it's got the elements 1, 3, 5, 7, and 9. So you can see 1, 3, 5, 7, 9 are all in part A, or set A. And in set B, you've got the numbers 1, 2, 3, 4, 5. Cool. So the intersection and the union are illustrated in the Venn diagram shown opposite. Alrighty, so here, just dialing it back, the intersection is where they overlap. So here, this part where they cross over is the intersection. And you can see that the numbers that are part of that set, or the elements that are part of that set, sorry, are 1, 3, and 5. Yep, so we've listed those. When we talk about the union is everything that's in A and everything that's in B and everything that's in A and B. Yep, so it's all of this stuff here. So in this particular case, A union B is, you can list off all of the elements that are in all of those sections there. Yep. Cool. Let's get rid of my scribble. Happy days. All right. Oh, a worked example. Yep. It says here, we've got a set A and we've got some elements. Check. We've got set B, we've got some elements. Check. It's asking us to find A intersection B. Okay, so remember A intersection B are the elements that are in both A and B. So if we're looking here, we need to find the elements that are in both of them. So there's a 1 is in here, there's no 1 in here. There's a 2 here, there's no 2 in this one. 3 is here. Oh, cool. And 3 is here. Oh, it's in both of them. Yep. They intersect. They're in both B and A. Yep. And 7 is here. And there's a 7 here. Cool. So both 3 and 7 appear or in both set A and B. They intersect. So you write out A intersection B. The elements are 3 and 7. They belong to both of those sets. Cool. Alrighty, next let's have a look. It says let's calculate A, or work out what A union B is. So remember, A union B is everything that's in both set A and in set B. Now, as we're looking here, you'll notice some people are tempted to write, okay, well, I've got 1, 2, 3, 7 here. I'll write those out. Then I'll write 3, 4, 5, 6, 7. Yep. You're kind of right there, but when elements are in both of them, you don't need to write them out twice. Yep, so you don't need to write, oh, there's a 3 here and a 3 there, then a 4, then a 5, then a 6, and a 7, and a 7. You just need to write them out once. Yep, so the elements that are in both of them, and in A or B, are listed there. Cool, happy days. Alrighty, what's next? Oh, cool! It's set difference time. It says, finally, we introduce the set difference of two sets, A and B. Oh, there's a symbol. It's like a little backslash. Yep. A set difference between B is listed here. So the set A set difference B contains the elements of A that are not elements of B. Cool. So again, you need to carefully work through these things. So you've got A, the set difference of B. You need to list out the elements that are in set A. You list out the elements that are in set B. And obviously then you need to work out and write out the elements that are in A but not in B. Yep. So the elements that are not in A are that are in A but not in B are 1 and 2. Yep. So it's working the other way around. This one here, write it out. Okay. And again, you're looking for the elements that are in B but not in A. Yep. B but not in A. So the elements that are in B but not in A are 4, 5, and 6. Cool. A little bit different there. Get your head around that one. Alrighty, next thing. Oh, yes, you need to know this stuff. Yep. It's different sets of numbers. Yep. So again, you need to recall that the elements of 1, 2, 3, and 4 are natural numbers. Cool. Yep. They're positive from 1 onwards. Yep. And then you've got the elements here where you might have some negative numbers, 0, 1, and 2. Where you've got negative and positive numbers, these are whole numbers. These are called integers. Cool. It says the numbers of the form P divided by Q, where P and Q are integers and Q is not 0, so when you're not dividing by 0, they are called rational numbers. Check. It says the real numbers which are not rational are called irrational numbers. Now, some of these numbers that you'll get are examples like pi and the square root of 2 and so forth. Now, when you are dealing with some of these things, they can be written using certain special letters. Yep. So it says the rationals may be characterized as being those real numbers that can be written as terminating or recurring decimals. So you've got some dot points. It says the set of real numbers will be denoted by the letter R. Cool. Real numbers R. Check. The set of rational numbers will be denoted by the letter Q. Cool. Q for rational numbers. Check. The set of integers will be denoted by Z. Yep. So integers, negative, 0, 1, and 2. Whole numbers, Z. The set of natural numbers will be denoted by N. Cool. Check. Now, here is how this works. Yep. it's saying here that n is a subset of z. Yep, so natural numbers are a part of integers. Yep. Integers are a part of rational numbers, and rational numbers are a part of real numbers. Yep, that's what that's talking about there. So when you're looking at it, everything is part of a real number. Now, there's different ways we need to describe a set. Cool, it says it's not always possible to list the elements of a set. Yep, because it could take a long time. You have to write, you know, a million numbers, etc. We want shorthand ways of doing this in maths, so it's especially useful when you're talking about infinite sets. Cool. So it says the set of x such that is denoted by thus. Okay, cool. So here are just some more examples here of explaining things. Yep. So if you had to describe the set of all real numbers strictly between 0 and 1, this is a way of writing it. This is read as follows. X is greater than 0, but x is less than 1. Yep. So obviously x is in between 0 and 1. So that's that one notation there. This is probably more straightforward for people to understand. Obviously it says here x is greater than or equal to 3. It's basically saying it's the set of all real numbers greater than or equal to 3. Cool, I think people should be fairly happy with that. Here, if you've got x is greater than 0, where x is rational, it could be written as follows. X is greater than 0, where x is an element of Q. Here, another way of writing this, you've got 2n, n equals 0, 1, 2, dot, which is really saying, okay, it could be 3, it could be 4. It's basically saying all non-negative even numbers. Yep. Here, again, where you've got n, again, this is even because 2 times every one of these is an even value. If you had 2 times the n value and you added 1, it's going to be the odd numbers. It's a way of writing a set of all non-negative odd numbers. Oh, alright. Are we getting anywhere? Yes, we are. This is the last bit we have to talk about. Oh, cool. It's interval notation. Yep. It says among the most important subsets of R, all real numbers, are intervals. It says the following is an exhaustive list of the various types of intervals and the standard notation for them. We suppose that A and B are real numbers, with A being less than B. Cool. So again, if you had to describe some numbers that were in between A and B, yep. Now notice again, essentially what you need to know is if you're talking about this is the lower value and this is the upper value over here on the right. If you're talking about just the less than or the greater than symbol but not the equals, you have to use the round brace around the outside. Yep. If it's less than or equal to or greater than and equal to, when you're dealing with this notation, it has to have a square brace or bracket around it. Yep. So it's important to note the difference between when you're using a round bracket and when you're using a square bracket. It's to do with whether it's less than or equal to. Yep. Another thing that you should note is what they're saying here is if you have one of the ends of the intervals is infinite or infinity, sorry, because you can never actually get to infinity and include it. Yep. So it's going to not be equal to infinity. Infinity always has to have the round brace around it. Yep. So never put, and the same applies for negative infinity. It has to have the round brace around it, never the square, because you can never include infinity. You can never actually get there. It's impossible. Yep. Cool. So let's have a look at how these intervals can be described Oh yeah, and you can also draw these on number lines. Yep. Oh, building upon that, again, if you are drawing these on the number line, if it's including less than and equal to or greater than or equal to, and you're drawing it on a number line, you have to use a closed circle. Cool, look at me drawing here. Closed circle, fun. If, because it's including it and it's equal to that. Yep. If it's just less than or greater than, it doesn't include it. When you are drawing it on the number line, you draw it as an open circle. Yep, it's got, you don't color it in. Yep. Alrighty, let's have a look here. It says illustrate each of the following intervals of real numbers. Okay, we want to show on a number line the numbers between -2 and 3. Notice it's got the square brackets, so it's including those values. So have a think about whether we use a open or closed circle. Oh, good, you were paying attention. We use a closed circle. I just spoke about that because it's including that. Yep. Square brace is including it. So you go draw up your number line. Happy days. I think you guys remember doing this from year 7. At -2, because it's including that, you put the circle. Close. Color it in. You go to 3 on your number line. Aha! It's included because it's got a square bracket. You color it in. This is saying, hey, what are the numbers between -2 and 3? You can represent that with a line in between those. Yep. Here we've got -3 and we've got 4, but watch out. One's got an open bracket, one's got a square bracket, but you don't need to panic because you know how to deal with that. So at -3, you got the round bracket, so it's not equal to at that particular point. It doesn't include it. So open circle at -3. Check. Go to 4 on the number line, square bracket, closed circle, color it in. This represents the numbers between -3, but not including number 3, so greater than -3, but less than and equal to 4. Yep, so you draw the line there. Here we've got -infinity to 5. Only real difference here is we've got to deal with -infinity. Note you can never actually include -infinity because it's impossible to get there, so it's a round bracket. And we've got 5. So again, on your number line, you'd go to 5. Square bracket means it's included. Numbers between -infinity and 5, obviously you can't go to -infinity, so you just represent it with a line that's saying, hey, it's going to go to -infinity. So between -infinity and 5 is represented as follows. I reckon you guys are all over -2 to 4, open circles, happy days. Likewise here, you've got -3 to infinity, open circle here, going to infinity is all the way this way. Yep. Cool. Oh, they spoke about the things I did. Cool. It says the following are subsets of real numbers for which we have special notation. Yeah, if you want to talk about positive real numbers, you can just write real numbers with a little plus. Negative real numbers can be with a negative. Real numbers excluding 0, you can write R excluding the 0 there in the element 0 in the braces. There's a fun, happy summary section that lists all the things we've spoken about. You might choose to put that into your summary notes. That would be good. And then you've got a whole fun exercise 5A to have a look at. That's it from me. Bye for now.